Okay, in heat, we need to understand how heat capacity or specific heat capacity can be determined using the calorimeter. So it's very important because calculations in heat is actually very disturbing, and the student would need to understand the experiment very well for you to solve problems relating to heat. So in this experiment, we are going to look at how we can determine the specific heat capacity of a solid material using electrical method. So how do we do that? Well, first of all, weigh a calorimeter when it is empty, and then when we weigh it, then we say let the what mass of the empty calorimeter be m1. So we write mass of empty calorimeter. So we take it to be what? M. Weigh it empty, and then we now insert a metallic block in it. So we insert a metallic block, we reweigh it. So we now say mass of calorimeter plus block. So, and that gives us M1. So we take that to be M1. Now, what do? We have a thermometer here, and then we have a heater here. So we now switch on the heater so that heater will supply electrical energy to the block. So the experiment, you know that the heater will be supplying heat to the block. The block will be what? Receiving the heat. But initially, before we do that, we'll have to measure the initial temperature of the block. So we have the initial temperature of block, okay, and that is theta 1. So when we must have passed the electric current for about 30 minutes, then we'll disconnect the experiment and then we'll measure the final temperature of the block. So, and the final temperature of block will be theta 2. Now, how do we now solve for the specific heat capacity of the block? So already we know that heat supplied is equal to what? The heat absorbed or received by the block. So what is the electrical heat supplied? And that is electrical energy. So an electrical energy. So electrical energy is equal to current multiplied by voltage multiplied by time. So that is IVT. Okay, so this is the electrical energy supplied. So heat energy received by the block. So heat energy received. So the heat energy received by a block is mass of the block times the specific heat capacity of the block times temperature change. Okay, so that means that heat received here is equal to mass times the specific heat capacity of the block times the temperature change, and that is theta 2 minus theta 1. So, but heat gain is equal to what? Heat loss, or heat received is equal to the heat supplied. Okay, so, and that's why we now have gained is equal to heat supplied. Okay, so heat supplied is IVT. Heat gained is M times specific heat capacity of the block times the temperature change. Okay, so and then we can make this to subjects, and that is IVT all over M bracket theta 2 minus theta 1. And this is how we can generate an expression for the specific heat capacity.